The first one, we're going to get it in this late cocking out here. So we're going to put it on in internal rotation. Now just remember, we'll come back and talk about this in a second. If you think of your force vectors, I'm going to start on a line up the limb, okay? Firstly, that'll make it easier to spiral around. Secondly, if you go too horizontal, you're going to get a tourniquet effect. You're going to affect their circulation or the neural tissue. But also, if you think in terms of your force vectors, okay, if I'm pulling in that direction up the limb, that's made up of a component vector this way and a component vector this way. Okay, remember your arrow diagrams you used to do in your physics? So the one that's up this way is going to give that lift and that weight relief like that technique we just did. And the one in this direction is going to resist rotation, okay? Nice big anchor points because this breaks down fairly easily on the arm, particularly the next technique. We're going to come on there. I'm going to spiral around to take up that soft tissue tension so I get good purchase on the lever. So I'm going to hold that anchor really well, take off a bit of paper, spiral around so that now I've got that secure. I can let go of this because that's all stuck, but I try not to lose my tension, okay? And the reason is I don't want to do little bit by little bit and create like a tension points underneath the arm or bunch up the skin, okay? So come through there, so let's pretend we've kept that on, and once I've done that I can keep him in internal rotation. The further the arm comes forward, the shorter this distance, which means the sooner it's going to tighten up, because then I'm just going to wrap straight across the front here, okay? So as the arm comes out and up, you'll feel that resisting. That's going to decelerate him into that late cocking and transition back into early acceleration. If I get it wrong, however, and my line of pull is a little bit too high, and I come across there, now when he goes to throw, you don't feel any resistance, eh?
Not as much.
So you've got to get down here. The more we can get across here, and the further I bring your elbow forward, okay, as I come around there, the sooner that's going to tighten up, the more resistance he's going to get as well, okay? So if, though, it was one of those posterior superior type impinging things in late cocking, they might actually like having a bit of an anterior inferior pressure or glide to reduce that impinging force in late cocking. So I could actually bring this down on a bit more of an angle, bring them into internal rotation still, and come around and get your line of about 45 degrees. And I'll often have them in sitting and rest their arm on my leg, so I can actually put a bit of a gliding force, if that makes a difference, down through there. So now what happens as they get up here, they're actually getting a bit of an anterior inferior gliding sort of force, okay? If he's a dislocator who's dislocating anteriorly and inferiorly, do I want to put an anterior and inferior glide on him? No. So for those ones, I'm going to bring him back around and I'm going to change my line of pull more up and in this way, right? So now when they get out here, the force is actually up and into the joint and he's got some restraint to anterior motion of the humeral head. Does that make sense? So again, depending on what your aim is, you can modify your line of pull and your position accordingly. Keep in mind too that your throwers generally have lots and lots of external rotation, right? So if we stick them on right around here, it's going to start resisting them here, when in our throwers we might want to resist way back in external rotation because they've got 180 degrees. Therefore, for those ones we might stick it on here rather than all the way around there. Does that make sense? So again, your position depends on your aim, depends on the person, what their range of motion is like, when you want it resisting and so on. Everybody okay with that? Glide, we're going to go that way. More approximation, we're going to come more straight across. Obviously on the ladies, coming down like that's not really practical. You've got to pretty much go straight across. In the PDF that we'll send you out, the book, we've got a version where we split it through the middle and we run one horizontally and one vertically. And that's so we keep tension in the system no matter what their degree of elevation. So what happens is in lower degrees of elevation, the horizontal one is under tension, and then as they come up over the top, the vertical one tightens up. So you can do that sort of thing as well.